Hello, everyone. It's great to be here for the second time. I'm Tomasz Gębarowski. I'm senior software engineer. For the last 2 years, I've been working at mBank, but recently I joined YND Consult, where I work as macOS and iOS developer. Today, I would like to take you on a subjective journey through common iOS anti-patterns. But first, let's start with something a bit different, that is code reviews. We all do code reviews, right? Lack of systematic code reviews in the longer run can lead to a code that is hard to maintain. But not all code reviews are really valuable. Have you ever thought why not all code reviews are valuable? Why some people give you better feedback during code reviews, while some do not simply comment on your pull requests at all? Of course, you may explain that with experience. That's obvious. That's simply writing, and what is even more important, reading lots of code, is something that really helps when you evaluate someone else's code. But is it really everything? Why some people are still not participating in the code review process? Why not all code reviews are really valuable? How is it possible, when I often ask my friends, how was it possible that they evaluated 500 lines of code pull request in 1 minute? It's impossible, but they do that. And they usually explain that they had their own tasks, they wanted to deliver fast, because those were the expectations of either the product owner or manager. Doing a good code review is something that definitely takes your time, as you need to understand someone else's perspective. But on the other hand, it also helps you to understand the architecture of the application itself and expand your knowledge beyond your field of expertise. Secondly, what is also very important, especially when the team mixes both junior and senior developer, is that junior developers are afraid of expressing their own opinion if there are some senior developers involved. They simply think that they could be wrong because they have less experience, they don't know the project that well, so they are a bit afraid of that. And lastly, what happens also in the teams where, for example, there is a mentor that has a great knowledge or is supposed to have good reputation, especially when doing code reviews, is that when pull request is evaluated by such a person, then usually it happens that there is a group of people in certain company that auto-accepts this pull request because it was already reviewed by someone with greater experience. And this happens, and this creates a bad impression that a given pull request was reviewed, for example, by 5 people, and in fact it was only checked by 1 person, and this person could have a worse day or could simply omit certain changes. So how to start with code reviews? For junior developers, I would recommend simple things, something that in the end could be automated with, for example, SonarQube, Lint, or CodeBit, so static code analysis. Those things that are easy to spot, but on the other hand, the things that give you the possibility to express your own opinion and break the ice within the team. So how to master code reviews? Well, most of us learn from errors. We experiment, we reason, we learn from others. So having a good mentor is something that definitely helps, because you can simply pick up good practices from such a person. And you can leverage the knowledge during code reviews in order to improve the process you are making. So take your time, make a code review a part of your daily routine, because it's an important process to write maintainable code. If you are afraid, observe first and comment later. Promote code review cultures within your company, because it's something that really has real benefits. And what is really important, try to limit the pull request size to a reasonable size, because pull requests that are longer than, for example, let's say 500 lines of code are really hard to check. So try to, if you are working on a bigger feature, try to divide it to sub-features Or if it's not possible, try to divide the pull request into commits that are logically ordered and described so that you could do the code review based on the commits level. And use checklists to standardize the process. So code review, what is it all about? I would say that code review is an art of sniffing code smells. So now what the code smells are. Code smells could be defined as certain structures within your code that violate fundamental design principles. Code smells are not bugs. They are technically correct. They do not stop your program from functioning. But they make your code harder to maintain. So they make your code harder to support in future because you have to spend much more time on working with that code in future when you want to either add some features on top or make some bug fixing. And those code smells can be a part of the checklist of when you are making code review. And code smells can be grouped into 3 categories based on the scope level, so the level of the impact. So we have method level code smells. Those are the easiest ones to find because they are limited to the function or method scope. Then we have class level code smells that are the smells that simply are limited to the single class. And then application level smells that are like related to the whole architecture, and those are the most difficult to find because they are involved like knowledge of the application itself and how it is designed, what are the patterns used, what are the interconnections, etc. So first, let's briefly go through method-level code smells. Most names are self-explanatory, like too short names, too many parameters, too much data that is returned, like in case of return values, with tuples or some structs that are either, for example, too complex and, for example, violating single responsibility principle, cyclomatic complexity, like too much nesting, partial methods, which are quite interesting because those are the methods that are simply invoked only under certain conditions. So when you execute such a method, you can't expect that something is really performed because there are some preconditions that has to be triggered. And most of those code smells can be found using static code analysis, like with Lint, SonarQube, CodeBit. And that's the easiest part of the smells that you can find in your code. Now let's move on to the class level smells, which are a bit more sophisticated, especially the names are a bit like saying less when you read them. These code smells, for example, among these code smells, we could have data clumps. So data clumps happen when we have 2 or 3 or 4 variables, a group of variables that you are passing all the time together to a function, for example, like for example, zip code, address, some location-related data. And this is a data clump, so this is a candidate to extract to some structure or another data type that you could simply use to pass these data together. We have refused bequest. Refused bequest is when you are using inheritance and when the subclasses are simply using only a portion of the functionality from the base class. Divergent change, so when we have some changes that we have to introduce when we change one thing in a class, then we have to make some sequential changes due to this change. So it's like one change triggers changes within the same class in lots of places. And feature envy, which is quite interesting, and which happens when you, for example, have a method that accesses properties from another object more than the properties of itself. So it's like envy for the feature. And lastly, application level, so the architecture level, the most difficult to find. I will go just briefly through them because then I have some examples that I will show you in real life what are the typical smells within the code, but just to have some general knowledge what are the possibility of smells. So we have, for example, contrived complexity. So this is when we are forced to use some overcomplicated design patterns where a simple pattern would suffice. So we are trying to invent something, some potential use cases, or just complicating the code. Then we have a shotgun surgery, which name could be funny, but in the end it happens when we have a class that when you change something in that class, it triggers like changes in distributed places in your code. So for example, you provide some method, and when you remove this method, you have to change some code in totally like in other classes that are related to this class. And speculative generality, when we have some unused class or field or some logic that is never executed because we added that just for future, just because we thought that it could be useful for some person, but in the end it's never used. And inappropriate intimacy, for example, when we have some dependencies of implementation details of another class. Okay, that's enough for the theory. Let's start our trip with some example. We all do JSON parsing, right? This is something that probably every mobile developer does, as we are exchanging data with JSON format. And probably this is the job that we don't like doing because it's very repetitive. We have some code generation that helps it. We have some third-party libraries. We have now with Swift Codable protocol that simplifies our life a lot. But this example is more or less related to that. Let us assume that we have a parse function. That parse function takes input string as an integer, and it returns an array of results. And this array is composed of 3 optionals. Because, yeah, we used optionals because we never know if we could get some data or not, because it's JSON, something could simply be not there. So let us define the structure. Optionals are quite frequently used, so we don't see any problem with that at that point. And then we may think that, okay, we have these 3 optionals. Maybe it would be nice to have some property that would indicate whether this result is good or bad. And the naive approach would be to create a property observer and have like this property set when we modify the mark value. And there is a code smell already there, but I will explain that on a 1 or 3 slide further. So note here that we are using nil coalescing operator as a way to fall back for the default value. So the nil coalescing operator is here. So we are like using a fallback to provide the default value in case the optional is nil. And then on the top of result, we thought that maybe we could have a nice formatter to print this result in a nicely way. And note that again here we are using like lots of nil coalescing operators, even here, maybe here not, but here, because of the decision that we made of using optionals in the result type. And lastly, we could introduce a function that calculates average. Average based on the array of results, returns some double. Of course, there is like an error in this code because it will crash when we have empty list, but it's not the scope of this. I just wanted to make it shorter. But here again, we have nil coalescing operator. We are providing default value when the optional is nil. So what is wrong with this code? First of all, when we introduce this isGood property, we are introducing a side effect. The property observer, when we change the mark value, is setting this value as a side effect. So as a consequence, we could, well, first of all, the consumer of our class may not know that it happens. So he can set this value and didn't know what happens, that some other value is set in the meantime. So it can generate problems, for example, when someone overrides this value from another place of code. So we could have a mismatch between the mark value and its property value, and its good value. So in this case, I think that we should eliminate side effects by trying to avoid these property observers for such cases when one property modifies another property, because it can, in the end, create some kind of chain of those changes. So later, another case, it's var here. We could promote immutability. So the var is something that is quite risky because this value should never actually be changed from the outside. Okay, another smell. Nil coalescing operator that is used in quite a lot of places here. First of all, it's used as a way to fall back to the default value. And in the end, we are using it in a copy and paste manner. Sometimes by accident, we can provide a different default value in other cases. So it's also a potential danger. It's an error-prone solution, mainly because we can provide different default values, and because we are like copying and pasting, so it could be a source of error. And lastly, the result printer, the class that we have here created for printing formatted results. It is a candidate for a feature envy class because it does nothing but just uses internal fields of another class just to print it in a formatted way. So it's a feature envy code smell. So what could be the improvements here? First of all, we could modify our parsing logic in a way that it parses the result correctly and either skips the results or initializes them fully with default values on the parsing level, so that we simply avoid using optionals in the result type. So this is like one improvement. The other improvement could be using computed properties to return is good, because we are avoiding this side effect. We are just returning a Boolean value basing on the value of the mark. The feature envy class could be eliminated by conforming to custom string convertible protocol with the description method that will simply return a string. So those were the very small improvements that we could introduce in our code to get rid of those code smells. Okay, now let's move on to another example, which is first question to you. Have you ever used a class that is named base view controller? I encountered that in quite a lot of projects. I asked my friends, and some of them answered that they used such a name. And it usually starts with a brilliant idea to have some common view controller that is shared between other controllers, like to provide some functionality that is common for all the view controllers in our application. And it sounds like a good idea because we have apps that definitely has some shared functionality. And in that view controller, we start to add functionality, like, for example, I see some funny faces because I know that you are using this pattern or used it at some point. So basically we are adding on top of that more and more functionality. Like, for example, here to disable swipe back action, so that user can't swipe back to go to the previous view controller. And it's something that you could implement with a flag, with some logic that is not important now, but it more or less it works in a similar way, that you create some gesture recognizers, you override some methods, register some gesture recognizer, etc. And then you can add another functionality like show activity indicator, hide activity indicator, etc., etc. Like, for example, handle left navigation bar item action just when you press the navigation bar item. So you want to invoke some logic. So what is wrong with this code? Well, first of all, we created a God object. So we created an object that is responsible for lots of things in our application. It's responsible for quite independent things, like, for example, blocking gestures or displaying navigation item or activity indicator. And in the end, it uses refused bequest because most of our view controllers are not using functionality from the base class. They are using just a small part of this functionality. So we have to override certain methods to block certain behavior or enable it. So in the base class, in the subclasses, we are overriding a lot just to disable certain actions. And lastly, base view controller, for me, it's not a good name. I don't like it. Probably it's because base is something that already says that it's something that lots of things happens there. And probably some shorter name could be invented. Okay, so how to make it better? Well, the first solution would be to be aware of base classes, base view controller. Of course, it's not possible in all the scenarios, especially when you have a bigger app, the app that is, well, really complex, that has some shared functionalities, then it's probably something that anyway should be reconsidered and done with some kind of base class. So the second solution would be to use a mixture of protocols and child view controllers. And with that, you could create behavior-like view controllers that would act as child view controllers, so they would have all the lifecycle methods, and those lifecycle methods would be just like in a normal view controller. And on top of that, you could introduce a protocol that would simply provide functionality, expose the functionality to register a given child view controller and add it as a child view controller to the parent view controller, set it hidden so it's not visible, so it acts only as a way of changing the behavior of the view controller. And we have a default implementation here for this protocol, which just registers this view controller and adds it as a child. And then we could create really a thin base view controller, which is in our case called view controller, which will simply check if we are conforming to a given protocol and register the given behavior view controller as a child. And an exemplary class, like here user view controller, could simply inherit from this, and we could use the module name so that we don't have any ambiguity if the view controller is used somewhere else. And we can extend our user view controller with a given type of behavior by simply conforming to this protocol. And we can push this pattern even further. We can, for example, introduce some protocols that would require some methods, like for providing action, or the name of the left navigation bar item. Or we could add more and more behaviors, like for activity indicator, for search controller, for empty states, for right navigation bar items, etc. And I think that it's quite a powerful pattern. It allows you to have these view controllers that act as behavior in separate features, in separate child view controllers that are like separate components that could be like just connected together to provide a given behavior to the view controller. Okay, now third example. We all love enums. Yes, this is a really powerful feature of Swift. And it is usually used when we have some styling involved, for example, when we have some paragraph style that we want to customize. So we introduce different cases like header, body, etc., title. And we use there quite often computed properties. So computed properties are returning correct value depending on the case of a given enum. And it looks nice. And then when you add another case, you have to extend the switch. It also looks nice because it's quite, well, it's self-explanatory. Then you start adding more computed properties to it. And you are, well, now it's when you have two switch statements, it's okay. It's not a problem. But when you add more, then you see that you are like copying and pasting the same switch all over again just to return different values. So what are the pitfalls here? The first one is that enum is violating open-close principle, so that it is closed for extension and it's open for modification. There is a switch statement smell, so we are returning different values, and we are copying and pasting the same switch statement all over again. And so this is something that maybe looks nice when you have like 2 switches or 3 switches, but I've seen code when you had like 10 switches of this type. And it's really not an elegant pattern. So the naive solution here would be to use aggregation to create some kind of structures to aggregate those values and reduce the number of switches we could have. But it's still violating open-close principle. So for example, if we would want to have a possibility to extend this pattern from another framework or module, it wouldn't be possible unless we had it in some commonly shared framework. So a better solution here would be to use protocols. So we could introduce a protocol that is paragraph style type that would have some attributes, and this protocol could like have structs in a nested way. so that we could refer to these values in a nicely and descriptive way. And we could conform to this and set corresponding values. And this approach is quite extensible because you can extend this paragraph style, so you could have paragraph style in a shared framework, and this could be extended in your submodules, so in frameworks that are using that framework. So in the end, the usage could be as simple as that. So it could have paragraph style type, and you could like just pass footer in a nice and descriptive way. Of course, you can push this pattern a little further, or you can modify it so that you don't have to construct the object. You could like have some static fields or something like that so that you don't have to create it all the time. Okay, let's do some UI now. Let us assume that we have a placeholder that we would like to create, and the placeholder is composed of UI, image view, and some labels. So it's like a very simple placeholder. Usually, you create it in zip. You could have a custom class that binds outlets between the view and the zip, and then you could have some view model, or it's not visible here. But you have a view model here. The view model has some fields. It just you set the view model. You expect the view to be changed, and then your designer comes to you and asks you to modify the placeholder so you have another version of it that is aligned at the bottom of the view. So then you start thinking, okay, let's make it generic. And now it's when all your problem starts. So you create a simple cell. You think that maybe let's use some layout constraints as IB outlets. Let's connect them. Let's modify the view model and introduce some margins that will update those constraints just to provide a different layout of this view. And then you start thinking, okay, maybe it's not a good idea because I don't want to specify those magic numbers in code in the view model. So you thought that maybe you could introduce enum here with a style. So the enum will be like used just to postpone your def sentence because in the end you will use those values in another place. So they will be there, but you don't have to copy and paste them all over again. So you introduce this enum. At the same time, you think that maybe you could introduce this case for the top because maybe someone else will use that at some point. So you add it everywhere. You are like adding, extending all those cases. So what are the problems here? First of all, we introduced here contrived complexity code smell. So we added some functionality that is not needed for now, but maybe someone else for the future would use it. So we complicated the rest of the code. We have some static magic numbers that are defined here that are hard to understand, especially when you connect both zips and view controllers and view from the code. So this is a bit hard to follow. It's good for animations, or to parameterize certain things, but if it's possible, I think that it should be avoided. And we have a switch statement smell again here that we are using switch to return some values. So then your designer comes to you and asks you to modify your code a bit, to put a button there that will allow you to set the placeholder. And with that, you start looking crazy because you know that something went wrong. So you use speculative generality to create something that was supposed to be generic, but in the end, you had the wrong abstraction. So you try to avoid copy and paste pattern, but you introduced solution that is quite prone to error simply because you have a single source that can be like accessed from different placeholders that are totally independent. So this is something that makes your code prone to regressions. And lastly, you had contrived complexity. The contrived complexity happened when you introduced this extra case for the top just for the future. And the solution here would be to prefer duplication over the wrong abstraction. So I would suggest here to have zips independent, one simple custom class that would just connect outlets And for the case with the button, you could have a simple subclass that would just introduce the button there. OK, now let's move on to the last example I have. So we have, let us assume that we have some event reporter. Event reporter, that would be like for publishing some analytics, for example, of the use of your application. So like gem use or some apps that are simply just pushing some feedback of the use of your application. So you could have some domain, event, scope, event, action. That would just be some parameters that are passed to a backend. Backend is the print function in our case. So it usually looks like having some big structure or enum with all the possible parameters that you have, you can pass to this backend. And a smart developer could introduce some auth reporter class that would just simplify the usage of this event reporter by providing some nicely described methods to pass correct parameters, just not to pass them all over again. And he could like create an instance here, use the same auth domain so you don't have to pass it, and all the parameters, the rest of the parameters. And this is a typical case for the middleman code smell. So you created an object that does nothing, but just puts different parameters to invocate some other method or methods, set of methods. And in the end, when you, for example, modify something here, like modify this enum, delete something, rename or something, then you have a shotgun surgery because you have to change it in lots of places. And you can imagine that quite often when you're publishing some events, they are quite unique. So you don't use the same events in lots of places because you want to distinguish between different places from which you are reporting. So you could have like 100 methods of this form. You're lucky if you could use code generation. But usually when you want to have descriptive ways, you can't generate them automatically because they won't be that descriptive. So this is something that involves like lots of copying and pasting and modifying the same set of code to change something. And lastly, with this big enum here, the big enum had, for example, if we want to have this analytics in some core framework, the framework that is shared between all the modules that we have in application, then this big enum would have to be put there too, because events reporter has to know about this, all the events, because they are like in enum that can't be like extended in an easy way. You can't extend cases from another module. So this is something that requires you to put this enum to some core framework. And with that, if you have all the events, the core framework would have to know more or less about all the events that are in your app. So if there are some feature teams that are working on some modules, then they have to constantly modify the core framework. So the solution here would be to use event type protocol, again, protocol. As you see, I like protocols. Well, you could introduce some static field, for example, that would determine the scope of this, the domain of this protocol with some associated types, scope and action. That would be later bound to your concrete implementations from the enums. And you will notice that on the next slide. But here, again, we have some default implementation just to return the domain from the name of the class. So you could introduce later a struct that would be like auth struct that conforms to this protocol, and it will simply bind those actions with scope with concrete versions from within the struct. So with this approach, you could introduce some generic event reporter that would simply take this as a parameter, and with the send method, you could simply use the template arguments to print correct values from and send them to your backend. So the exemplary usage in this case would be like you create event reporter with the auth and use everything from like later the usage would be like auth.scope.menu, so just to push a given type of information to the backend. And with this pattern, you can extend, you could have the protocol here in the core framework, the generic event reporter in the core framework, but all the modules that are providing certain type of functionality can basically extend this protocol and conform to this protocol to provide corresponding values that are passed to the backend. So this gives you a possibility to make your solution in a more modular way. Okay, to sum up a bit different perspective on the code smells that I mentioned, this is like the categorization that takes into account their impact, so the type of the changes that we have to make to avoid them. So like, or the impact based on the code complexity. So we have bloaters that are like making your code hard to read, like long names, long classes, some data clumps, excessive return of data that I mentioned, change preventers that are simply making your code harder to change. When you want to change something, you simply try to avoid it because you know the consequences. So we have like divergent change, shotgun surgery that I described, or parallel inheritance hierarchy, which happens when you have when you inherit from something, and at the same time you have to inherit from another class hierarchy just for the code to compile, for example, or to work. And then we have dispensables. So those are like code smells that are when there is some kind of code that is not really used. Some not up-to-date comments could be a good example, or duplicated code, or for example that code that is the code that's never executed, or speculative generality, so some generic patterns or some code invented for the future. And couplers, so like introducing dependencies that could be avoided, like the middleman, feature envy that I mentioned, inappropriate intimacy or message chain, so like invocation of the blocks in a sequence. And lastly, we have object orientation abusers, the switch statement I mentioned, refused bequest, and temporary field that I haven't mentioned, but which occurs when you have a given field that is used to synchronize between a set of methods from within your class. So this is like a good candidate to extract those methods with that field to another class. Okay, that would be everything for the code smells part. I hope that you enjoyed the presentation. It's reviewing someone else's code is definitely not an easy task, but remember that even though you are an experienced developer, something that you should never evaluate someone else but the code that is written by that person. So don't be personal, don't treat code reviews as a personal thing, but just try to evaluate the code and never be personal. So don't treat that the code reviews. It's just a way of improving your code base, not a way to blame someone for the code that was written. Thank you, and if you have any questions, I would be glad to answer.
You made a deep dive on the technical side of the review, but I wonder, do you have any more advice on the harder part, in my opinion, so respectfully communicating things in review and creating environment of learning and trust?
Well, the first advice would be, if you want to write something bad about the code, just wait 1 minute, 2 minutes, 5 minutes, and just relax, because quite often when you work under pressure, when you want to make the review in a fast way, you are like trying to say too much and just take a distance, take a perspective, just to avoid like blaming someone else, because yeah, that's like the first suggestion. Then I would also recommend trying to encourage everyone to take part in the code review process and to check that everyone takes part, so there are no simple people who are added there and do not comment on the pull request. So you could have some statistics, for example, to to notice what was the real evaluation time of the pull request. What else? I don't know, is it satisfying you, or you want me to elaborate more on that topic?
How much praise you put in your reviews? Because you have to put some praise to not make it on criticizing, right?
Yeah, it's quite hard because it depends on the. For sure, if I see that the code is not perfect or there are some potential dangers, I want to communicate it. I don't want to, because I'm a friend with someone, I don't want to avoid trying to express my own opinion. I'm trying to be polite, but in the end, what is evaluated is the code, not the person. So if there are some issues, I'm trying to communicate them. I have some caps for the question, for the people who ask questions. So I don't know if maybe later you can come to me.
So how to be happy when you maintain the same code base for more than 2 years, for example?
Okay, that's a tricky question. I think that you can always find some positive sides when you work with the same code base, especially when, well, first of all, there is like a constant rotation in the team, so you can learn everything, like new things from new people. Well, you can try to improve your code base, so you can try to pay off the technical debt, and it's nice if this is something that is also considered within your team. So if there are no like tasks at that moment, that you can dedicate your time to pay off the technical debt, or for example, introduce some features that are proposed by the developers. So it will be like finding a balance between like maintaining new features, and of course it depends on the project. But I think that 2 years it's not a long time, so you could like probably within 2 years you can get to know the project in details. But in the end, there could be still some interesting things that happen there. I worked in one company for 7 years. Of course, I changed projects there, so I couldn't say that I was involved in the same project for 7 years. But at some point, there were projects that I was working on from the beginning, and in the last year of working there, I also had some influence in that project. So 2 years, I wouldn't say that it's a long time.
Yes, I wonder if you have any like base of knowledge that you all agree in your code reviews, right? So let's say that we have one approach to solve some problem, the other, and both of them have some impediments, but you just need to choose one.
That's a tricky question because, well, I think that it happens in every team when there are developers that want to like, I don't want to say fight, but they want to persuade other person that this approach is better, and it usually is a matter of talking with others and deciding together what is a better solution. It's a problem when there is like when the team is small and there are only 2 developers, but usually it's not just a matter of discussion. And of course, there are some patterns that you can agree to when you start working with the project. So I hope that it's not a matter like whether we're using tabs or spaces, because this should be agreed in the beginning of the project. But there are some decisions like the patterns that you could use there that could be discussed. The conventions should be discussed, because this is something that you should either agree when you start the project, or what you should adapt when you continue like maintaining a project. For sure, you shouldn't like revolutionize the project and change all the patterns that were used by someone else if they are good. So if, for example, a new developer joins a company and he wants to like revolutionize the architecture because he worked in another company and, for example, used RX Swift, so now he wants to introduce it everywhere, probably it's something that shouldn't be discussed unless there is some like real good motivation behind that decision. But in the end, what should be, well, there are some conventions that you should agree in the beginning. You could modify them in the end, but when you work and you see that some pattern is simply not working or something better was introduced. But when the app is bigger, when it has quite a lot of users, those decisions are usually hard because then you have to retest everything in the application. So some decisions probably, those that were taken in the beginning of the process, may be really hard to change when your app is already released and used by hundreds of users or thousands of users or millions of users.
There are some guidelines in project that are just growing with the time. It is not like we should follow always solid principles or anything else that Uncle Bob says, for instance.
Well, in theory we should, but the reality is like you don't have a chance quite often to start a project from scratch, and there's some existing legacy code. So I would say that what Uncle Bob says is something that is the ideal world, but the reality is different.
Yeah. Okay.
So I've never met a project that would be like perfectly done according to what Uncle Bob says, the clean architecture. There are still some parts that could be that we could refactor, or like refactoring is an endless process.
Yeah.
You like look from a distance at your code in a year, and you will always find something that you could refactor or you could like reduce because something else was modified.
Okay. Thank you.